Hello, everyone. I'm one of the two main presenters for this workshop today. My name is Alex Townsend. I'm one of the application specialists at the Research Computing Center. If you've never heard of us before, we are a department of the Information Technology Services that runs and manages the supercomputer at FSU. We also do a lot of support. We also do a lot of support for researchers who need computing support, and we run these tutorials as well. Thanks. The other main presenter is Marcelina Nogales, who's sitting in the back here. She's going to be helping me with the presentation by presenting some examples of Linux commands, which will be showing up both on the screen here for those of you on Zoom and also on the projector here for those of you in person. Marcelina Nogales is also a scientific application specialist, and she's one of the leads for RCC's new IDHI Digital Humanities initiative. So just a quick overview of what this presentation is going to be about. We're going to cover a little bit about what an operating system is and how an operating system works. And then we're going to dive into exactly what Linux is and how the Linux operating system works. And we'll also cover a little bit about how the Linux file system works. Once we get through the basics of Linux, the basic operating system concepts and the basic file system concepts, then we'll go into applications. We'll teach you a little bit about the Linux terminal, and we'll show you some examples of useful commands in the Linux terminal. For those of you on Zoom, if you have any questions at any point, please put them in the chat, and Marcelina and our two other helpers, Jose Hernandez, Casey McLaughlin one of them will help answer your questions in the chat. For those of you in person, if you have a question, please just raise your hand. So to start, we need a couple of definitions. The first and most obvious question is, what is an operating system? And an operating system is basically it's basically a piece of software that acts as a middleman between you, the user, and the hardware or the computer system you're working on. It's the piece of software that interacts with the digital electronics in your computer, and to basically conduct them a bit like an orchestra and make those little digital chips and those CPUs and all of those digital circuits work together in a way that's useful. It's also the main logistics center of the computer. And by that, I mean it handles resource and memory allocation. It handles scheduling of tasks and interactions, efficiency and power management. If you ever notice, for example, if you're on, I think Windows does this, you might see sometimes when your battery's getting low, your screen will start to dim down a little bit. Sorry. Your screen will start to dim down a little bit, and you might get a little indication, a little battery symbol indication in the top right hand in one of the corners of your screen. That's an example of a program running automatically in the background that checks your battery level and tries to optimize the battery usage and by manipulating the backlight, manipulating all the other lighting and stuff, so that you can get as much battery life out. You can get as much life out of your battery as possible. The other thing it does is the operating system is the main sort of logistics center that allows you to have multiple programs running at the same time. You might have, Microsoft Word up and running. You might have a web browser up and running. You might have a terminal up and running. The fact that you can use all of those together at the same time is an example of how an operating system kind of acts as a logistics manager by allowing you to schedule those tasks, by allowing those tasks to be scheduled on the hardware seamlessly, such that you can switch back and forth between them without really noticing too much difference. So for most people these days, most people, including me, start with the world of computers with Windows. Windows is by far the most common operating system. Some people might start out with iOS, the Apple main operating system. those are the two, those are by far the two most common that people start with. However, those are primarily used in the areas of business, just regular computer interactions. They're used a lot. They're used a lot in healthcare. They're used a lot in just general business. Linux, however, there are many other operating systems aside from just Windows and Linux, or aside from just Windows and iOS. Linux is one of them, and it's the third biggest after Windows in terms of market share after Windows and iOS. There are other ones that you might never have heard of, and I didn't know about until not that long ago. Examples of those include BSD, Solaris. There's a whole bunch of other ones. There are actually whole groups of people that write their own operating systems for fun. So the list. So if you really wanted a comprehensive list of all the operating systems in the world, it's a very, very, very long list. However, the market share is basically Windows is by far the biggest, followed by iOS, followed by Linux, and then maybe 1 or 2% is everything else. So why Linux? Linux is really useful because it's an open source operating system. Open source means that it's on top of meaning in this case that it's free. Most distributions of Linux, with a handful of exceptions, are freely available. You can just go to the distribution's website, download it, and install it, and it's free. But open source also means that anyone can contribute to the development of the operating system. And that might sound dangerous, but actually it's kind of the opposite. It works a bit like crowdfunding in a way. And what I mean by that is even though anybody can contribute to the operating system, there's usually a core team of developers who contribute a lot of time to the development of that, and they will catch and stop anybody from putting bad code into the operating system. And they also check and watch, and they're sort of gatekeepers for contributions. So in general, the crowdsourcing aspect of open source often leads to better and higher quality software, and it also leads to the ability to catch and fix bugs and other software problems a lot quicker than might otherwise be possible with closed source software. Linux is also itself a derivative from Linus Torvalds' Unix system. Linus Torvalds is a really famous computer scientist from Finland, I believe, or maybe Sweden. It's either Sweden or Finland, but he's a very famous computer scientist who first invented the Unix operating system. And Unix is to this day the core. Unix is to this day the core system upon which all Linux distributions are built, or almost all of them. Linux is very, very different from Windows, and as a result of these differences, it is fundamentally incompatible with Windows. If you try and install a program that was built for Windows on a Linux system, it will not work. And likewise, if you try and install a program that was built for Linux on Windows, it usually will not work either. And
So is Unix an operating system? Yeah,
Unix is the old original operating system from when it's a generic name. It's the old original core from which Linux and all of its derivatives were built. Yeah.
Might be wrong, but when I hear Unix, what should I be doing?
I would think of old original. Think of it as the old original. Linux is what everybody uses. Unix is sort of like the original test bed.
Well, it's not very true. It's more a generic term for Linux. We use the Solaris, etc.
Okay, so Unix is.
Well, when people say Unix, it can mean Linux. Okay, it's kind of confusing.
Okay, so for those of you who didn't hear our director Paul Vandermark in the back, so he made a very good correction, and that is that Unix is actually a generic term for Linux, BSD, Solaris. It's a generic term for all of the Unix-like operating, for all of the Linux-like operating systems.
Like zero.
Yeah.
Oh.
Thank you.
Yeah,
So Linux is so that's all interesting and stuff, but why is Linux actually important? Well, Linux is actually used a lot in scientific computing applications. So if you end up doing research in physics or engineering, or more and more these days, if you do research at all, you're going to end up seeing Linux, because a lot of that's because a lot of research software, particularly the free and open source research software, it was originally built on Linux for Linux. Many of them have ports to Windows nowadays, or are built on something that's cross-platform, like the Java platform. But a lot of research software is developed, at least at first, for Linux systems. So as a result, it gets used a lot as the main platform for research. The other main place you'll see a lot of it, you'll see Linux very commonly, is in high performance computing. So if you ever have to interact with a supercomputing cluster like FSU's or any other university's or supercomputer, or maybe your industries or businesses HPC system, you'll almost certainly run into a Linux operating system. The reason for that is when operating systems like Windows, on top of being closed source, they're also very expensive. So modern supercomputing clusters tend to be very, very large groups of computers, not too dissimilar from what you might have from a desktop tower you might see in your office. It's usually lots and lots and lots of those wired together and built in such a way to work interactively. And so as a result, each one of those computers has to have an operating system installed on it. So for example, if you have a supercomputer with 500 computers wired together, it's going to be really expensive to install Windows on all of them. So the way most HPC centers mitigate that is by using Linux instead. It's just way, way cheaper, and also a lot of the multi-computer programs, the programs that can run on multiple computers at once, a lot of those are also built primarily for Linux. So another important point of difference between Windows and Linux, although this is becoming less and less true with time, is the difference between a graphical user interface and a command line interface. A graphical user interface is just a term for your everyday Windows application. Anything you bring up, and it's very visual, and you can point and click, and you can click on it to start, you can click on it to interact with it. That's a graphical user interface. A command line interface, on the other hand, is usually just a screen with text. If anybody was, I'm going to make myself sound really old here, but if anybody was around in the early 90s or late 80s and they work with computers, you might have seen a command line interface, because the old computers back in the day were all command line. And so that's basically just screen text, and the only way to interact with it, you can't use your mouse, is you have to type in commands. So the typical way of comparing these two comparing Linux and Windows used to be that Linux was primarily a command line interface operating system, and Windows was primarily a graphical user interface operating system. This is becoming less and less true with time. More and more Linux varieties, such as Ubuntu, Fedora, Manjaro, and a whole host of others, and we'll look at a sort of tree of life of the various Linux varieties in just a minute here. More and more, a lot of the more widely used Linux varieties are becoming more and more graphical user interface like. A lot of them have graphical user interfaces that you can use almost like Windows nowadays. The only thing is that to really make the best use of Linux, you really need to know a little bit about the terminal. You really need to know a little bit about the command line interface. So another big difference between Windows and Linux, and a lot of this is down to just the fact that Linux is open source and Windows is not, is that Windows tends to be very monolithic with its versions. You have one version of Windows at any given time, sometimes two, maybe three, but usually it's one at a time. You have Windows 95, then you go to Windows 98, then ME, then XP, then 7, then 8, then 10, then 12, or whatever they're on now. Linux, on the other hand, tends to do this sort of tree of life thing that you might see on the right hand side of the screen here. It originally started out with a very small handful of varieties that were more or less similar, but still somewhat incompatible. And from those, because they're open source, people can also take the code and make their own derivative of it. So new varieties of Linux spring up all the time, whereas you might have originally had Debian, Red Hat, and Arch Linux. Now you have Manjaro Linux that's derived from Arch Linux. Now you have whole separate standalone varieties such as Void Linux. From Debian, you have Ubuntu, you have Linux Mint, you have a whole bunch of other ones. You have Debian itself still around. And from Red Hat, you have a whole bunch of derivatives like Fedora. You have CentOS, which is the operating system the HPC, the supercomputer here at FSU uses. And you have a whole bunch of other ones. I think even Scientific Linux is built on that, but I don't know. Yes?
I guess with the different versions, if you know one version, you can see versions.
Yes, that's one of the main nice things about Linux is that for the most part, the command line, the commands you use in the terminal are going to be identical for the most part. The applications are going to work in much the same way. One of the big points of difference between a lot of these Linux varieties is something called a package manager, and that's just a little program that helps you find software to install and installs it for you. So a lot of these Linux distributions come with their own package manager, and so that would be the one point of difference. Also, in the background, there are some minor differences, but you're probably not going to see too many of them at the user level. Yeah. As far as I know, Linux is primarily written in C. So the question for people on Zoom was, what programming language is Linux written in? As far as I know, it's primarily written in C. I think some of the more modern stuff might have C++. And down at the very, very core, there's a little bit of x86 assembly, but not very much. So are there any other questions about basic Linux and operating systems before we move on to file systems? Yeah, sure. Yes. Oh, that's actually a really good point. So the question was, what is x86? Thank you for mentioning that. The x86-64 is one of a handful of digital CPU architectures. It's not something as a user you're really ever going to really notice the difference with, but it's one of several different hardware architectures. At the user level with Linux, you can install Linux on x86 architecture. There's ARM architecture. There's MIPS architecture. There's a whole bunch of other architectures, and you can install Linux on them. And those Linux installations will all, for the user, it will all feel pretty much the same. It's just that there's a little bit of difference in the background. Any other questions? Okay. So the next important thing to talk about are file systems. So file systems, you can kind of think of them as like a big file cabinet. Like you might see file cabinets in your professor's office or in a business manager's office. They're usually these big file cabinets that have drawers that hold a bunch of folders. You can kind of think of a file system a bit like that. File systems are basically just the big box that holds all your folders, programs, files, pictures, videos, and documents, and organizes them for you. Now, one of the big differences between a file system and a file cabinet that you might have seen is that file cabinets are usually very flat in their structure. You open them and there's a whole, you open one drawer and there's a whole bunch of folders. You open another drawer and there's a whole bunch of folders. With a file system, they're usually organized hierarchically. So you can kind of think of that as if you open one drawer and you open a folder, there might be a bunch of other folders in there. And then you can pull out one folder, open that, there might be a bunch of folders within there. And as a result, file systems tend to have a much more three-dimensional structure than file cabinets do. This is actually really useful because it allows you to have a lot finer control over how you organize the stuff on your computer and it allows you to organize that, and it gives you a lot more control over how you organize that than over how you might organize papers in a file cabinet. And all of these, and this hierarchical structure is all stored on your computer's hard drive. Hard drives come in many flavors nowadays. It used to be, back when I was a kid, it used to be that they were these there were these little rectangular boxes that had a disk sitting in them spinning, and that disk had a little pin that had a laser on it, and that laser would mess with the optical properties of the disk, and by doing that it would write data to that disk or read data from that disk. Nowadays there's a whole bunch of other architectures. One of the big ones is something called solid state drives. Those tend to be a lot faster than the spinning disk drives. And those are, I'm not entirely sure how those work, but those are basically, my understanding of those is that they're basically really scaled up versions of how a thumb drive might work. And those are usually meaning that they're basically just a whole cluster of transistors that are written to by electrical signals rather than a laser. So file systems have this tree-like hierarchical structure that I was talking about, and all file systems, even Windows, start at something called the root. The root is exactly what it might be for a tree. It's the core of the tree. It's where it's rooted to the ground. And this is the highest level in the directory structure. And this is usually where all of the important system files are installed. And all other files and folders are usually contained within that. So you can kind of think of this using the file cabinet analogy as if you open one, as your file cabinet has one drawer, you open that drawer, that's the root drawer. Now, any folder you pull out of that, you open the folder, it might have a whole bunch of other folders within it. Then you can pull out one of those subfolders. There'll be a bunch of folders within that. So in a way, all of the folders, so in a way that folder structure starts at that first cabinet, and everything else is sort of a subfolder within that. In Linux, this folder is usually just called // it's not a very interesting name, but it's the way the Linux people came up with it. In Windows, it's usually a little bit harder to figure out. The closest equivalent is My Computer. So if you go to the My Computer folder on Windows, you'll see a bunch of different hard drives and a bunch of physical devices. So the closest equivalent on Windows is My Computer in the control panel. So in Windows, files are usually organized within the root directory according to the physical device they're stored on. So if you go to a control panel in Windows and you go to My Computer, you might see the little folders within there called C:\\. That's C:\\. is almost always the main physical hard drive. And it's usually the same one that Windows itself is installed on. There's also E:\\, which is usually E and F:\\, which are usually other hard drives. So those are if you happen to have a really fancy computer that has a whole bunch of hard drives installed in it and usually has a whole bunch of storage. Then there's things like I:\\, which might be a network drive, and usually other letters like maybe L, M, or K that are like removable external devices. And this picture here is just an example of what that might look like on on the control panel. In Linux, however, files are organized according to a concept called mount. And what that generally means is it gives you a lot more control over where it is that Linux is not so concerned with exactly what the physical device structure is. It's more concerned about what should go. It's more concerned about what things need to be within what subfolder. So, for example, you can mount a physical device anywhere within the Linux system. However, most Linux systems tend to have the main root being / that's usually the primary hard drive, /mnt/serv SRV might be a network server mount. Again, MNT is just a placeholder where you can hold a whole bunch of other physical devices. You can hold a whole bunch of other file systems. You could even have different file systems on the same hard disk mounted to different places within the Linux operating system. It's a very different approach to things than Windows. So all files and folders on your computer can be located using something called a path. And a path you can really think of as kind of a set of directions for how do I get from that first file cabinet drawer, how do I go through folders and subfolders and subfolders and subfolders until I find the individual file that you want me to find. For example, and this is similar on both Windows and Linux. For example, on Linux, if I wanted to find this presentation, it might be in a folder called it might be in a file called presentation.odp. And the .odp there just refers to that's an open office presentation format. So if that is stored in my home directory and it's sort of like my documents folder, that might be stored in Linux on /home/alex/documents/workshop /presentation.odp. And what that means is if you open that file cabinet, that file cabinet is called /. And if I then go and look for a folder called home, I pull out that folder, and then I open that folder and I go look for a subfolder within that called Alex. Now I pull out that folder and I open that folder and I go looking for another folder called documents. And I do that again for workshops. And then finally, once I get to the workshop subfolder, I should be able to look through all the files in there and I should be able to find a presentation.odp file. And these paths like this are basically like a set of street directions. Like, first, if you want to go from here to the Woodward parking garage, for example, you might say, okay, start from here, walk out the front door to Duroc Science Library. Now turn left, walk to the sidewalk. Now turn left again, walk down to the roundabout. Now at the roundabout, continue forward now walk around the roundabout until you reach the set of stairs. Now you're at the Woodward parking garage. That's sort of the English or like the human language equivalent of how paths work in computer systems. In Windows, the equivalent might be C:/, starting on the C hard drive, then going into the documents folder on that hard drive, then into the workshops folder within the documents folder on that hard drive, and then finally within that folder, there should be a PowerPoint for this presentation. So I know I covered a lot, but are there any questions? Yeah.
We need to specify, I remember when I was doing something, I allocated some spaces for directly and making phone, but after leaving that for 2 days, I was making one that my phone directly. So is it possible to allocate spaces after the operating system or doing stuff?
Yeah, I think so, but you have to be really careful with that. You have to be really careful to make sure you reallocate. So the question is, for those on on Zoom. If you install, if you create a partition on your hard drive and you install Ubuntu onto there, is it possible to then resize that partition? And the answer is, I believe so, but you have to be very, very careful, because that can lead, because resizing that after you've installed can lead to file corruption. The best way to deal with that is to copy all of your contents to an external hard drive, wipe the computer, and then reinstall Ubuntu, and repartition your hard disk, and then reinstall Ubuntu with a larger partition, because it has something to do with the file system, and I'm by no means an expert on that, but it has something to do with the file system not liking to be resized, because when you add a whole bunch more space, the file system's already there and it doesn't quite know where to put that space. So usually you have to rebuild the structure from the root. Any other questions? Yeah.
Basic core, the thing is the root or the kernel?
The basic core of the operating system is the kernel. The basic core of the file system is the root. And if you're looking for files and folders, the root is the most important thing. Yeah.
I don't know how much my question is going to be correct, but
That's okay.
what about the safety of the operator?
Safety?
Like Windows has firewall.
Yes. So that's a really good question. The question is, what about safety and security? Are there equivalents on Linux to Windows security features? The answer is Linux. There are Linux firewalls. I don't know if they're configured by default, but you can absolutely configure them. There are a whole bunch of antivirus softwares that will work on Linux, but they're not usually things like Norton Antivirus or AVG or things like that you might have seen. There are Linux antivirus software. There are certainly firewalls and things called access control lists, which those access control lists basically are a list of things that determine what other computers can talk to your computer. There are firewalls that you can configure that will determine what files can be downloaded to your system, that will determine who can talk to your computer and in what capacity. There's also a very important separation in Linux between the user and the administrator. Generally, whereas Windows might run a whole bunch of stuff as administrator in the background, with Linux, you really can't do that. You as the user, you have to enter the something called the sudo command, which is the run this as administrator command. You have to issue that command to the terminal to allow any process to go forward as administrator. So there's a little bit of security there. There are also antivirus software. ClamAV is the big one that I know of.
It doesn't come built in anything.
No. But Windows, I think they haven't really come up with anything like Windows Defender yet. Yeah.
One more question.
Sure.
What's the difference between OS and BIOS?
So the operating system is actually built on top of the BIOS. The BIOS, so BIOS is something called a basic, stands for basic input output system. And it is basically it is a little piece of software that runs on the CPU itself. And its only job is to load the operating system into memory. And from there boot up the operating system. That's really its only job. Now you need to have it, because if you don't have it, then the operating system will be utterly useless. But it is sort of the first step to the operating system. Yeah.
BIOS for control like the electrical levels and everything. Like if you wanted to like go and talk and you do the BIOS
That I'm not totally sure about, but I'm not a hardware person, but I believe that's correct. Are there any other questions? So the next And so the next important thing we're going to talk about is the Linux terminal. The Linux terminal is basically, this is the command line interface that I was talking about earlier. In general, when you're working with a command line operating system, when you're working with a command line interface version of the operating system, the general progression of interaction starts with you, the user, entering a command on the terminal. There are many, many, many different names for this terminal. The terminal can be called the command line, it can be called the shell, it can be called the terminal. For all intents and purposes, they're the same thing. There are slight differences on the computer science level, but for all users' purposes, they're basically the same thing. So you will enter a command into the terminal. The terminal will then interpret that command into something called a system call, and that system call is a different command that is designed to be interpreted and understood by the kernel, which is the core of the operating system that is designed to interact directly with the hardware. And so, but generally the progression goes: you enter a command, the terminal interprets the command into a system call. The kernel then interprets that system call and goes and does stuff on the hardware for you. And once it's done stuff, it goes back up through the kernel to the terminal to you, and you get your output from there. So, as I said earlier, the Linux terminal is the main point of interaction for Linux and Linux-like operating systems. This is becoming, and I also said this is becoming less and less true with time. However, for a lot of things on Linux, you're still going to need the terminal. A lot of software installation, you're going to need the terminal for. A lot of configuring firewalls, for example, you'll probably need the terminal for. Some networking things you might need the terminal for, and any sort of high-level administrator level interaction between you and the computer, you're going to need the terminal for. If you've ever seen the terminal on Mac or iOS, iOS terminals and Linux terminals are very, very similar. They're both something called POSIX compliant, and POSIX is just an international standard that defines operating system compatibility. So it's a layer that lets iOS talk to Linux, and it's a layer that lets different Linux varieties talk to each other in certain limited ways. Notably, Windows is not POSIX compliant, so as a result, this is one of the main points of incompatibility between Windows and Linux. So as a result, Windows really has a hard time talking to Linux and the iOS systems, and vice versa.
Sorry, and I
Yeah,
don't
sure.
follow with that incompatible part.
Oh, yeah.
Why did you say it was incompatible with
Oh,
Windows?
sorry.
I'm trying to use
Oh, no.
Windows subsystem.
Okay, so the Linux subsystem for Windows is actually something very interesting. The Linux subsystem for Windows is you can sort of think of it as a little box that Windows has created that you can put Linux into. Now, you're not going to be able to go from that Linux subsystem out to your Windows system, and you're not going to be able to go back and forth because the two operating systems really don't like to talk to each other very much. There are certain ways around that. There's something called Wine, which stands for Wine is not a Windows emulator. And that is one way that's one program you can use to install Windows things on a Linux computer, but it's kind of hacky, and it's not a perfect solution.
I like you guys don't recommend it.
Hmm?
I think you don't recommend it.
I wouldn't recommend it unless you really need it. So because of that fundamental POSIX, because of the fact that Windows is not POSIX compliant, it's not compliant with the international standard. It doesn't have a lot of the even low level interoperabilities with Linux and Mac. But Linux and Mac are both POSIX compliant. They both comply with the standard. So to a certain degree, you can interact with both of them. A lot of stuff that's compiled for Linux will also work on iOS, and vice versa. But not with Windows. And things like Cygwin and Linux Subsystem for Windows and MOBA Xterm, those are all basic. Those are all software emulators that do this sort of pretend to look like Linux. Like MOBA Xterm and Cygwin will pretend to look like Linux without actually being Linux. Linux Subsystem for Windows puts a Linux distribution in a box and basically says, okay, you can go and play with Linux over here, but you can't go back out to your Windows system and vice versa. And the Linux Subsystem for Windows also, as far as I know, last time I tried it, they only install the command line version. So you have to pretty much interact with the command line there. I don't know if they even install the graphical interface anymore. Or at least I tried it years ago and I don't know if they do anymore. They might have fixed it since then. So as I was saying, yes. Oh, sorry. So as I was saying, the Linux terminal is the main point of interaction between you and the Linux operating system. It is the point from which you issue commands to the operating system to perform tasks. It also has some tools that allow you to monitor the operation health of the computer. You can look at memory usage. You can also do you can also run file system checks to see if there's any memory that's corrupted. And there's a whole bunch of other things you can do with it. You can also connect to other computers using the terminal. There's a very common program called Secure Shell program, which in the Linux terminal is the SSH command. This allows you to directly log into another Linux system if you have the password and if you have the credentials, and if your computer is recognized and authorized by that other computer to do so. So Secure Shell kind of acts like a remote desktop protocol for the terminal. If you've ever logged into a computer remotely, done a remote desktop session, SSH is the equivalent of that for the terminal. So are there any questions about the basic Linux terminal stuff before we move into useful commands? Yes. I'm sorry?
Putty.
PUTT or PuTTY is actually, so for those of you on Zoom, the question was, how would you classify PuTTY? PuTTY, as far as I know, that's a Secure Shell client. So what it does is it holds the Secure Shell protocol within. It's got a Secure Shell program built into it, and what it will do is you'll enter the computer you want to log into, and usually there's something called the port you want to log into via. That's sort of like which door do you want to go through. And then what it will do is it will start a Secure Shell session, and it will bring up a window in which a terminal will be, in which you'll have a Linux terminal. And on that Linux terminal, you'll be able to interact with the computer you've logged into. So it's something called a Secure Shell client. There's actually a whole bunch of those. It's really useful for a lot of stuff. Are there any other questions?
I'm on Windows and I'm supposed to use Pine, right?
PuTTY?
Yeah.
You don't have to. There are many Windows. If you only want to use the terminal, actually Windows PowerShell now comes with Secure Shell. So you can actually just run the SSH command from your PowerShell terminal. Otherwise, you can use MOBA Xterm that comes with a Secure Shell. Cygwin, I think, also comes with Secure Shell, and most Linux emulators you're going to use are going to come with Secure Shell. And I think also Linux Subsystem for Windows has it. Are there any other questions? If not, in that case, we're going to move on to the sort of a field guide to useful commands in the terminal. And for this, I'm going to have Marcelia Nogales helping me. She's going to be demonstrating the commands in real time. So you'll be able to see them on the screen in Zoom, and you'll be able to see them running, and you'll be able to see the actual how it works up here on the screen.
Is this being recorded?
Yes. Yes, it's been, oh, that's actually a good point. So thank you for reminding me. This is being recorded, and after the session, probably a few days after the session, after the libraries has had time to go through it and fix it up and clean it up. Everybody who registered for this session will get an email with a link to the video. I think they usually put it on YouTube nowadays. And you'll also get a link to the slides. Yep, yes.
What, for Windows, what terminal can we use to try to solve this?
So for the question is, if you're on Windows, what terminal can you use? PowerShell probably will not have most of the Linux commands you need. The best thing to do is either to use Linux Subsystem for Windows or to use a Linux terminal emulator like Cygwin, which is spelled Cygwin, or MobaXterm, which is MobaXterm. Both of those are free to download. The MobaXterm has a paid version, but don't download that. You don't need it. Any other questions? Okay. In that case, do you want to switch this to the
Well, there's some text first. Before we switch it.
Oh, yes, thank you. So in that case, we're going to proceed with a little field guide of useful commands in the Linux terminal. So we're going to go through a bunch of different categories of commands. The first one is navigating the file system through the command line terminal, through the terminal. We're also going to demonstrate commands for how to find stuff in the file system on the terminal. We're going to go through some useful commands for viewing files and for viewing, editing, and deleting and creating files on the terminal. We will go through some useful command line text editors, and we will go through some useful commands for how do you get help with commands? How do you find little guides and help text for these commands? So the first thing to know about commands is that commands all follow a very common, they all follow a common structure. When you issue a command to the terminal, it always starts with something called the command executable. This is the command itself. This is the name of the command, and this is basically the name of the command. And when I say executable, what I mean is it's a little program that the terminal knows where to find it, and it will run that command, and it will run that program that is tied to that command. Now, most of these commands also come with a whole bunch of options. You can do a lot of these commands let you do the same thing more or less in a lot of very different ways. So for example, you might have, these are usually followed by these options are usually preceded either by 1 dash or 2 dashes. So and then lastly, you have the argument. And what this is the file or folder that you want the command to actually work on. So for example, this command here, ls-l-a/home/bob, what that will do is it will go, assuming there's a folder called Bob within the home folder on the root, which is a subfolder of the root folder. What this ls command will do is it will list all of the files that are within the Bob folder in the home folder. It will list them using these -l and -a options. What that means, what the -l option means that it will list all of the files one by one with a whole bunch of information about those files. And the -a option means it will list all of the files, including hidden files and folders. So on Windows, you might have, Windows has this too. They have things called hidden folders. These are usually folders that when you bring up My Documents, they're not immediately visible. And these are usually system folders. They're often places where programs store caches. They're places where programs store a bunch of like intermediate system data that the user doesn't usually need to see. Linux has these too, but by using the by using the -A option, you can list out all the files, including these. So you can kind of think of these commands in terms of human language. You can kind of they generally follow a verb adjective noun structure. So the command executable itself can be thought of as a command to say do something, and the options can be thought of as adjectives like using method Y, and the noun and the argument can be thought of as sort of a noun saying at location Z. So for example, the ls-la/home/bob command I just covered, you could turn that into English by saying what that command is saying is do a listing of all the files, including hidden files, and using the method that gives me a bunch of information about each files, and do that listing for all the files within the /home/bob folder. So this is the general structure of how pretty much all the commands we're going to cover today work. So now we're going to go into the live coding part of this. So Marcelina is going to help me by demonstrating these commands on the screen. Everybody on Zoom should be able to see Marcelina's terminal, and you all should be able to follow along up here. So the first command we're going to cover is the whoami command. The whoami command is a simple command that doesn't require any other options or any arguments. Now what it does is it will simply tell you what user you are. So most computers nowadays can have multiple users on a single computer. So you might have, for example, you might have a user called Alex, you might have a user called Bob, you might have a user called Jane. All three of those will have their own home directories and their own separate file structures. By typing the whoami command, you can find out which user you are currently logged in as. So the next command we're going to cover is the hostname command. The hostname command also doesn't need any extra options and doesn't need an argument. And what it does is it will tell you what the name of the computer you're currently on is. And yeah, yes, this is a Linux terminal. So one thing with the Linux terminal is that the Linux terminal can look many different ways. We set this terminal up to use black text on a white background, primarily because that was the easiest thing that would show up on the projector. I mean, that's the projector's the projector is a little bit screwed up. But there's a whole bunch of different themes you can use. There's things like the Cobalt theme, which will usually be blue, white, and which will be like blue, white, and gray text on a black background. And there's many other options. So the hostname command will tell you what the name of the computer you're on currently is. So whenever you install an operating system, a lot of times one of the steps you'll have to go through when installing the operating system is give this computer a name. Usually is give this computer a name. So you'll have a lot of times they'll say something like Alex's laptop or Alex's desktop. That is the host name of the computer. Usually, and that computer can then have multiple users logged in. So you could have Alex at Pop! OS, Alex at Alex's desktop, Alex at Alex's laptop, so on and so forth. Many operating systems will come with a default computer name. Like for example, my laptop comes with a default name, Dell XPS 13. That's the model and make of my computer. So if I was logged into my terminal, you might see Alex at Dell XPS 13, and that's just the default. name. I can change that if I want. So if you're logged into a different computer, you might see a different through the SSH command we were talking about earlier. You might be able to type the host name and see a different computer name. This is really useful if you're going to be doing remote session, if you're going to be logging in remotely to other computers. It's really useful it's really useful because then you can know which computer you're on at any given time. And if you're going to be working with things like the supercomputer, or you're going to be working with big systems that you have to log into remotely, this is one good way to know exactly which system you're on at any given time. So the next command we're going to cover is the date command. This also doesn't need any options, and it doesn't need any arguments. What this will do is it's simply going to tell you the current date, time, time zone, and year and day of the week. So this is just a simple, useful command if you happen to be working on the command line and forget what day it is. The next thing we're going to cover is the free command. So the free command is a command that also doesn't necessarily have to have any options or arguments. And what it will do is it will look through the current partition on your hard drive. So it'll look through your hard drive, the parts of the hard drive that your operating system is allowed to look at, and it will tell you how much memory you have free. So for example, here you have, and another important thing is it always reports these in units of bytes. So a byte is, so in this case, a byte is either 16, 32, or 64 bits, and a bit is just a single 1 or 0. Generally, a byte is one set of 16 ones and zeros, or 32 ones and zeros, or 64 ones and zeros. And that depends on the architecture of your computer. This can be a little hard to read. So if you run, I think this will work. It's free-h. If you type free-h, so if you type free-h, that is that dash h says, give me the amount of memory that I have free on my operating system, but give it to me in a human readable form. And that means that it'll translate those bytes into gigabytes, kilobytes, megabytes. And so from here, huh? Not going there. But that's a useful distinction, but it has to do with numbering systems. But the dash h command will allow you to look at the total amount of memory you have free left on your computer, and you can see it by the total amount of memory that's available on this system, which is in this case 15 gigabytes. The total amount that's been used and the total amount that's free. This happens to just be one. This just happens to be because we're logged into one of the partitions. It's pretty small. But if you were to, yeah, this happens to be the swap. Swap is one of a bunch of different partitions. There's many different partitions, and in this case, we're looking at the swap for some reason. But that's just one partition. If you're working in a different partition and looking at a different partition, generally that would be a lot bigger.
Size of swap partition. So how big that should be, or
I'll take his offline with it.
That's a good question for our director. So the next command we're going to cover is the df command. So the df command without any options will list out all of the. It will go through and list all of the file systems that are currently mounted to your current Linux file system, and it will list out how much free space is on all of them. So in this case, we have the tempfs dev/nvme temp, a couple of different tempfs's and a couple of different NVMe drives. These these are simply different individual partitions of Marcelina's hard drive in this case. And in this case, they also without any options, it will list out the amount of free memory on each of those partitions in bytes. If you do df-h, it will list it out in a more human readable format. It'll give you units like M for megabytes, G for gigabytes. And in this case, you can see exactly how much space is available on each of these partitions of the hard disk, and how much has been used and how much is left. And it'll also give you a little percentage of how much has been used. And it will also tell you what folder those file systems have been stuck into. So the next command we're going to cover. Yes.
Can I grab the?
Yeah.
Yeah, so as you can tell, my screen's getting really full with all of the data that we've been putting on the screen. And so I'm gonna jump a little bit ahead to a command that's super helpful called clear. And so it's spelled C-L-E-A-R. And then when you click enter, it clears your entire screen so that you don't have to see your previous commands, and you can start kind of from a clean slate. But if you scroll up, or not, but if you
Type the up key.
Yeah, if you click the up key, you can see all of the commands that you've previously used before. And then if you click the down key, you can kind of go through those commands. So they're not completely gone, they're just not visible on your screen. The next command that we have is pwd. pwd will tell you what your current working directory is. So given Alex's example from before, it'll tell you exactly which folder that you're working in right now. So for me, we're in /home/Marcelina Nogales, which is essentially my my computer, the main slot for the hard drive. Yeah, so we're kind of a little bit we're getting close to time, so I'm just gonna speed up the commands a little bit. So going into navigating the Linux file system, Alex mentioned before that ls -l-a /home/bob will actually look at all of the files within /home/bob. So if you just type ls, it'll actually just look at all the files that are in the current working directory, which we have previously, it's /home/Marcelina Nogales. And these are all of the files that I have in my home directory. The example that Alex gave before is ls-l-a, which will give you a lot more information on the same exact files. And this is kind of a little bit messy in terms of viewing, just because it's a lot easier to see on the projector as this big screen. But typically all of the information will be located in one line, and the formatting will be a little bit complicated when you change the size. And we can actually, the next thing that we'll talk about is actually the permissions of going into, that's kind of visible here. So these are all permissions for each of the files and the folders that we have. And these you can see are appended next to each of the files. So we'll jump really quickly back into the slides for Alex to talk about.
Yeah, so this is actually important, going back to a question we had earlier about security on Linux systems. One way of helping to add security to your system is that you as the owner of a file, or you as the administrator, have the ability to change to determine who is able to view all of the files on your system. You have the ability to change you have the ability to group files into specific groups of people who are allowed to see and work with certain groups of files. You can group files together such that only certain groups of people can see them or work with them. And you can also ensure that only the administrator or only the owner of the file is allowed to interact with those files. When you look at ls-l, you'll generally get a big printout of files that looks something like this line here at the bottom of the screen. And the first set of that is the first set of things that you'll see printed out on the left-hand side of the screen there are something called the file permissions. This is a set of 10 letters that give you a representation of who has permission to view that file, who has permission to read to it, who has permission to read the file, who has permission to add to or delete that file, and who has permission to run the file if it happens to be a program. So generally, when you look at these file permissions, the first letter is either a D or a dash, and that indicates whether it's a file or a folder. If the first letter is a D, then it's a folder. Then the object in question is a folder. If it's a dash, then it's a file. The first group of 3 letters after that are the permissions that the owner of the file has. Now, if we go back to this slide before, you'll see 2 places where the name Alex is listed. Those are the name of the owner of the file in question and the name of the group that file happens to be assigned to. And group is one way of controlling who has or what group of people have access to certain groups of resources. So the second group of 3 letters are the permissions for the group. And the last group of 3 letters are the permissions for everyone else who is logged into that computer, or anyone else who has a user account on that computer. Now this is useful because again, you have to have, if anyone else accesses your computer, they have to be able to access it in the first place, which access control lists, firewalls, user IP address whitelists and blacklists can help control. So each of these three groups of letters contain an R, a W, and an X. And each one of these can either be R or dash, W. The first one can either be R or dash, the second one can be W or dash, and the third one can be X or dash. Thanks. And what the first letter means is either yes, the owner group or all other users can read the file, or if it's an R or if it's a dash, then know that set of users cannot read that file. If the second letter is a W, then yes, then either the owner of that group of users or everyone can write to that file or delete the file. If it's a dash, then that permission is not granted to either the owner of the group or the user or everyone else. And the X letter at the very end is a set of permissions that says this file is actually an executable program, and either all users, the group, or the owner is allowed to run this program. If instead of that X you see a dash, then that set of users does not have permission to run that folder or that file. So now we'll go back into more Linux file system things. And so Marcelina will go back to the commands. And once again, let me mention that this is being recorded. So after this session, if anybody has to leave early, you'll get an email probably a few days to a week later with a link to the recording on YouTube, along with either a link or the PDF of the slides. So the next command we're going to cover is the locate command. The locate command will allow you to it will allow you to type in the name of a file, and the program will, and the locate command will go through your entire file system, or all the files it has permission to read, and it will look for the name of, and it will look for a file that has the name you give it. So for example, if you say locate, myfile.txt, it will locate that. It will go through your file system and say, okay, do I have a file called myfile.txt?
Okay, so the error that you see right now, it says command locate not found, but can be installed with sudo app install. And so that basically means that I don't have the locate program on my computer, because it is not, because there are some programs that aren't available with base Linux. So for example, my Alex mentioned earlier that there are a lot of different variations on Linux systems. And so mine is a variation of that Linux system. It's Pop OS. And so sudo is another thing that Alex mentioned before, where you would have to give administrative permissions to download this program, so then it can run on your computer. So that's to explain what's happening with the error there. But there are, I think another, there are just like a couple different things, because Alex and I are very used to working in the terminal that we might have forgotten to mention. But when it comes to commands, it is case sensitive. So Casey mentioned this in the Zoom call, or in the Zoom chat, but if you were to type in the previous command that we were looking at before was free-h, right? And so that produces the translated version of free. But if we were to do free-H, it would actually give you completely different results. And that's because the free-H is the help command.
Help option.
The help option. Yeah. So again, with the verbs and the adjectives that Alex mentioned before, this option will actually show you all the different options that you can use for the free command.
And most most commands that you'll be using do have some variation of they're either lowercase h, --help, or uppercase -h. And most commands will have something that will print out help for how to use it. So another command we could look at is the find command, and this should be default on all Linux systems. So if I do find /-name and then my file, this is actually an interesting variation where what it's saying is, I want to find a program called my file, and I want you, and the first option is saying start at the root file system. The find command can start at pretty much any file. It can start at any folder you want it to start at, but you have to give it the full path to where you want it to start. The -name option says what's going to come immediately after this is the name of the file, I want you to find. So yeah, so the next group of commands we're going to cover are some commands for viewing files on the command line. So
yeah,
I'll turn over to Marcelina for that.
Yeah, so since we only have around 15 minutes left, we'll just go through the PowerPoint itself and talk about the commands, because we want to make sure that we at least expose you and talk about like maybe any commands that you guys can see on the screen that you have questions about, that we can answer right here, right now. So yeah, so okay, so something that we didn't cover before that we'll probably tack on to at the end is part of the navigating process for the terminal, and it's CD will allow you to kind of move in between the folders So CD space and then whatever the directory is that you want to move into, that is your typical command for moving back and forth into that. So to get into specifically viewing files on the command line, there's 4 different options. What cat will do is cat space and then the file name will actually output all of the contents of the file onto the screen all at once. So if you have a really large file, you're going to reach the end of the file and you won't be able to kind of scroll up unless you have a mouse. Less is a better option for this. It will print some of the text onto the screen, but then it will allow you to click the down arrow and scroll and read more of the text file. And it's 1 line at a time. For head, it prints the first 10 lines of the file, and then tail will print the last 10 lines of the file. So head, I think, makes sense in terms of you want to make sure that your file has content in it. And then for tail, a common use of tail is to make sure that you, if you're coding something that requires you to go through an entire file, and you just want to make sure that the new file that's created from that content reached the end of the previous file, to print the last 10 lines would mean like, oh yes, the bottom of the file is exactly where I want it to be. Okay, so deleting files on the command line. There's a big bold. I tried to make it as bold as possible because this is the most dangerous slide on this PowerPoint, which is something that's never been said ever. But deleting files on the command line is very dangerous. Like, at your own risk, be very careful because there is no undo button. There is no trash can that you can pull your files out of if you remove them, and there's no recycle bin. I know between different operating systems, trash can, recycle bin, that exists in the GUI form where you can take your files out if you accidentally delete them. You cannot do that with these commands. So we have 3 different commands here and 3 different options. Remove space X will just remove that X file. Remove star.txt will delete all the text files in the current working directory. So it will just do it within the specific folder that you are working in right now. And then rmdir removes the X folder in your current working directory, but only if it is empty, right? If it is not empty, it'll actually give you an error message that says this folder is not empty, could not delete.
So in that case, you have to go in and so in that case, you would have to change directory into that folder, delete all the contents of that folder, change directories back out of that folder, and then do rmdir on that folder.
Thank you. So going into creating the files, there's a couple different ways of doing this. We'll get into it a little bit too when we go into editing files on the command line, but if you just want to create an empty file, you can just just use the command touch, and then file.txt will create the file.txt if it isn't already created. If file.txt already exists, it will just update the last edited value. So that's a little bit of a nuance, but essentially you don't actually have to go in and open the file. You can just touch it and it'll update like the last modified version, or the last time that this file was accessed was whenever you ran the touch command instead of having to open it. Mkdir is a way of making a new folder. And so this will actually make it in the current directory that you're in. Again, the current folder that you were working in, it'll make a new directory. And then these are 2 commands that are a little bit more complicated. So I'll just kind of leave them here just to mention. But there's a way that you can move files, and then there's a way that you can copy files. And these, again, are very syntax specific. So if you accidentally like switch up whether you want the destination first and then the source after, it'll actually erase what you have. So you want to make sure that the file that you're moving and or copying is the first file that you list, and then where you want to move it or where you want to copy it is the second. So that's the source and destination is the file, and the current file that you're moving and or copying. Yes.
The source and destination, is that gonna be like the path name
Yes.
or the file name?
So it'll be both. So the example that Alex gave was for this path specific for the presentation.PowerPoint. And so you want to make sure that you have that whole path there to make sure that you're getting the right one. It's not completely necessary all of the time, because if you just list the file itself and it's in your current working directory, like the folder that you're currently in, then it will be able to find it. But if you don't tell it, like if it's somewhere else in a different folder, then the computer might say like, oh, this folder doesn't exist, this file doesn't exist. So yeah. Yeah, are there any questions? Sorry, I know I'm moving really, really fast.
Any command to extract the file on a certain file from the program to Windows? It's kind of from the program that is in on Windows.
For what exactly?
When I want to extract from my phone,
Mhm,
I want to extract a file,
mhm.
so I can want to. That's software.
So yeah, anything you like create or make on your command line will show up in your file explorer on Windows. So they're connected. Is that the question or not really?
Yeah, I can go to it.
Okay. Are there any questions online? Okay. Yes, okay. Okay. All right, so we'll skip over that. So essentially, I know we introduced a lot of different Linux commands, and we talked a little bit about like the help aspect of like trying to figure out what's happening with the Linux commands, like the options that you have. So these are a couple different options when you want more information about a Linux command that you're not quite familiar with. So you can do man space ls and find out all of the same information on like the different flags, the different options that you have, and that kind of stuff. So type and which kind of tell you where the program is located on your computer. And what is man and info kind of do the same thing, where they give you those options and they describe like, this is what this function, or this is what this command does, and that kind of stuff. Yeah. Okay. And then we covered a little bit of this as I was just navigating through on the terminal. If you want to clear the terminal screen, so that way it's not full of information, you can just type clear and enter, and it'll just move your, it will move the command prompt up. The up arrow will allow you to go back to the last command, and it'll input it in the same place that you would normally type commands. Tab will complete the typing, like allowing you to type out a command. And I will do a little bit of a tutorial, a brief tutorial.
Tab is sort of an autocomplete.
Yeah, so it doesn't autocomplete if it already, for example, if you have a really long file name, but you have a unique like first 3 letters, you can type in those first 3 letters and tab, and it'll type the rest of it out for you.
Assuming I can find it.
Assuming you can find it in your current working folder. History will allow you to do what the up arrow does, but it fills your screen with the commands that you've typed for the last however much space you have on your current screen. I mentioned less and cat when you are pulling up the information from files just to view. It doesn't really, like, you kind of can't press down to leave that view. You would have to press Q, and sometimes it doesn't tell you. So we're making sure that you know how to exit instead of having to like close out of the terminal and come back in. Q is the way to exit from less or man, or whenever you're looking up extra information.
Yeah, some commands like less and more allow you So some commands like less and more allow you to scroll within a certain file using the up and down arrow keys, but you can't click the up and down arrow keys to get out of that file. So in order to get out of the file when you're looking at it unless you have to hit the Q key.
And then the last command that we have here is to exit the terminal, you just need to type exit and enter. It's essentially the same thing as clicking the X on the top right corner, but this just allows you to do it from the command prompt. So you can really do a lot of different things in the terminal. Just to wrap things up, we do.
To tell that man is really important.
Yes, man is super important. Man kind of will give you a lot of information. We did cover that when we talked about getting help with Linux commands, but that will be your bread and butter for if you don't know what a command does, just do man, M-A-N space, and then the command, and it'll give you the options. It'll describe what is happening with the program and that kind of stuff.
It's
Yes.
short for manual.
What if you don't know the command? For example, I want to do like copy and paste. I don't know the command.
Yeah, so if you want to check out, you can actually look a lot of the stuff online about like if you want to do something, there's a lot of resources. We're also a resource as we have a lot of use with the terminal at the Research Computing Center. So you can always come ask us, but there are you have access to these slides, and then there's also a free Linux book that you can kind of look up, like, what if I want to do this? It'll kind of give you, these are the commands that will allow you to do that.
You can also always use, you can also always use Google for that. Google is a really good resource for looking up different commands, because Google will almost always have the answer for you. So you can type in Google something like, how do I copy and paste in Linux terminal, and it should, one of the first few results should be the CP command that we showed briefly before. Or how do I cut and paste? You'll probably, one of the first few results should be the MV command. So as Marcelina said, on top of Google and this Linux book and the link to this Linux book, there you can also always come by the Research Computing Center. We're located on the first floor, and we're located on the first floor of the Dirac Science Library, which can be a little hard to find. In this slide, underlined, I believe this is a link. Underlined. So underlined where it says located, that's a link that will take you to our location page, and it'll tell you how to find us. You can also email us at support@rcc.fsu.edu. Can one of you type that in the chat too, please? So I don't have anything up here, but I will bring up the terminal. Where is that? Where is the mouse? Where'd it go? There. Nah, it's good enough. So just to make sure you have it up on the screen, you can always email us at support@rcc.fsu.edu. This is our email address, and you're more than welcome to email us with questions about Linux or questions about HPC resources, questions about computer resources in general.
Under these slides.
We will email. So you can actually, if you don't get a link for these slides in the next few days with the email from registration, please email us at support@rcc.fsu.edu, and we'll be more than happy to share the slides with you. So I ran over just a little bit, but are there any last questions?
What's the difference between locate and find?
So locate doesn't give you a lot of control over where to start looking. Find gives you actually the first option you have to give to find is where to start looking. So for example, locate will look through everything on your system to find the file you're looking for, or locate will look through all the files, but find, you can actually tell it what path should I start looking at. And by doing that, it can actually, if you have a really, really big file system, it can actually speed up the process of finding the file, really, if you know part of where it might be.
So another big difference with locate was currently your operating system makes a snapshot of files on your system. And locate looks in the data notes, so if you don't know what a file is, it pinpoints a file on your files because it's a cache. Find actually to burn the system. So find can be very slow in some of the whole file system. But locate uses a cache. But like Alex said, if you know where to find it, if it's something in your home directory, you find it.
Yes.
My last question, which
course.
version of Linux would you recommend?
So to get started, I would actually recommend Ubuntu. Ubuntu is very much aimed at being one of the most user friendly. It's one of the most widely used Linux operating systems, and it's also got quite a lot of good forums and online user support. So that's a good place to start. Any other questions?
How do you spell
course.
Ubuntu?
Ubuntu is spelled UBUNTU. So
Linux also has GUI.
yes, if you install Ubuntu on your computer, not through Linux subsystem for Windows, but if you install it on your computer, then it will come with a graphical user interface. There's usually many different options, but Ubuntu usually downloads automatically with the GNOME graphical user interface. So when you start working with Linux, you'll be working through the graphical user interface. But when you need to do certain things, you'll have to pull up the terminal. Like installing software is one of the big ones. Are there any other questions? Any other questions from online? All right. Well, in that case, thank you all very much for attending. And as I said before, feel free to email us if you have any questions, and also email us at support@rcc.fc.edu if for any reason you don't get the slides in the next few days to a week from the libraries. Feel free to email us and we'll be more than happy to share the slides with you. Thank you very much.